And the last topic that you're going to have to be included on your midterm is going to be molarity. And molarity, I know that I'm a nerd, and that's okay. But it is one of my favorite topics, and it's quite simple. And when we're talking about molarity, it is the chemistry way of talking about how concentrated a solution is. And so when I explain this to a class or to my students, I talk to them about Southern tea. Now, it may sound from hearing my voice, because I've been in Arkansas for a long time, but I was not raised in Arkansas. I am the product of a military background. My father was in the military and retired from the armed services, and so I traveled all over the place, and I was not raised in Arkansas at all, and I am privileged to have lived in many different places. But I did not understand the meaning of Southern tea until we moved to Arkansas. And I am married, though, for many years to a born and died in the wool Arkansas man. And when I was introduced to his family and had dinner with them for the first time and politely asked for tea, I was expecting what I considered tea, a normal glass of tea, not Arkansas sweet tea, which you could pour on pancakes as syrup. So when we're talking about concentration of things, you can make your tea in many different ways. You can make it very weak with just a smidge bit of sugar, or you can make Arkansas sweet tea that you can't even put enough sugar in there unless you have super hot, almost boiling water, or else all the sugar won't dissolve. Or you can put any amount of sugar in between, or you can have your tea unsweetened. It is completely your choice. You can put any amount of sugar that you want. For that matter, you can put any number of tea bags in your tea as you desire. You can have very strong tea, or you can have very weak tea as they prefer, is my understanding, in some European countries, and anything in between. Same thing goes with coffee, and the same thing goes with chemicals. You can make a solution where you would take your water or whatever is your dissolving medium, your solvent, and you can pour a little bit of whatever you're wishing to dissolve, your solute, or you can make it much stronger and pour a lot of solute in it, depending upon your purpose for that solution. And you measure that by a term called molarity, and you do so by the number of moles of solute divided by the liters of solution. This is the definition of molarity. And so if you get a 6 molar solution, that is much more concentrated than a 1 molar or a 0.1 molar, which is very typical in the lab. Okay, this is known as concentration. This is this term that's given to you on this page. The amount of solute dissolved in your solvent or solution. Okay, and here you see some examples. Concentrated, lots and lots of molecules in the dissolved, or dilute. Here's your formula for molarity, moles over liters. We already know what a mole is. A mole is a number of particles. That number happens to be a large number of particles, 6.02 times 10 to the 23rd. That's one you better know for your midterm, 6.02 times 10 to the 23rd. The symbol for molarity is a capital M. And here's the sample problem that you have from your textbook. If you have glucose, that's sugar, and you're wanting to put it in a 2-liter solution, and it has 50 grams of sugar, what is the concentration? Okay, so if we were to do this, 50 grams of glucose in 2 liters of solution, first thing that we would need to do is we would need to figure out what is, how many moles is that. So, glucose is C6H12O6. And if I have 50 grams, how many moles is that? Well, I'm going to come over here to my scratch paper, and I'm going to say 6 times 12.01. I'm getting that off the chart, off the periodic table, and I have 12 times 1.01, and then I have 6 times 16. This is 72.06. This one is 12.12. And this one is 96, I do believe. And if I were to add those together, that's going to be 18. That's a 0. Carry that. That's 10. That's 18. 180.18. So for every 1 mole of glucose, I have 180.18 grams. So if I want to I'm using my calculator now, that's what you hear me doing. I'm saying 50 divided by 180.18, and that is 0.2775, which is 0.278 moles. Okay? And then it tells me, it's asking me for molarity. Well, I know that molarity equals moles of glucose over liters of solution. So that would be 0.278 moles of glucose over, and the problem said I had 2 liters of solution. So I'm going to take my 0.278 and I'm going to divide that by 2 liters. So it's 0.139 molar. That's my molarity. That's exactly how you'd do that. So it's pretty straightforward, I think. Okay? And you can see that that's exactly how she did it, 0.139. Part B here says to find the volume of this solution that would contain 0.250 moles of glucose. So for part B, if you know the molarity, then you could find the number of liters. And you could see exactly what she's done there. I would not have done it this way myself, personally. I would have, I'll show you exactly what I would have done. I would have said, instead of doing it her way, I would have done, I know my molarity, and I would want you to use molarity as a conversion factor. And the problem read, it had 0.25 moles. My given is 0.250 moles of glucose. And for every 1 mole, 0.139 moles for each 1 liter. That's what the word molar means, moles per liter. And since I got this is my molarity in part A, that means that I have 0.139 moles for every liter. So then I can just say that 0.250 divided by 0.139, and I get 1.80 liters just like she did. But I used unit analysis or dimensional analysis to get it. So we're going to get in the same way. And letter C, again, asks the same kind of question. How many moles are there in 0.5 liters? So again, I would use 0.5 liters as a given in a conversion factor. I would do like so. I would say my given is 0.500 liters of solution. SOLN is the abbreviation for now, and I know that my molarity is 0.139 molar, which means 1 liter of solution I have, I'll turn that upside down. For every 1 liter of solution I have 0.139 moles. So then you're going to take 0.5 times 0.139, and you get 0.0695 moles. That's what you would do there. Okay. And these are dilution problems, which I like very much. Dilution problems. Dilution problems simply means, and we do it all the time. Let's go back to our tea example. If you are ever at a restaurant and you order tea or coffee or whatever, and you get it and it's too strong for you, a very simple solution, other than getting the waitress to bring you more, is to simply take your water and dilute it. That's a dilution problem. And the same thing can be done if you have a strong acid and you want to make it weaker, or you have a strong solution and you want to make it weaker, you simply dilute it. But in the chemistry lab, you'll want to be quite careful, and you certainly want to know how strong your new solution is. And so in doing dilution problems, you can find the new molarity by this formula right here. The molarity of your concentrated times the liters or milliliters, this could easily be milliliters, of your concentrated is equal to the molarity of your diluted times your liters of your diluted. And most of the time, she uses millimoles. I've always used just moles of your diluted. And so the same thing can be true for acids and bases if you're using an acid and a base to do a titration. And so we'll be talking about that shortly too. So this is your sample problem that's in your textbook, sample problem 4.9. What volume of 12 molar hydrochloric must be used to make 250 milliliters of a 0.125 molar solution. So we're going to use milliliters times molarity equals milliliters times molarity. It's quite simple to do. Milliliters times molarity, this is of the stronger concentrated, is going to equal milliliters of the dilute times the molarity of the dilute. My strong stuff is 12, and I want to know how many milliliters do I need. So I'm going to put a question mark or an X right here. How many milliliters of my 12 molar do I need to make 250 milliliters of 0.125 molar? So I'd multiply the 250 times the 0.125. 250 times 0.125. And then I'm going to divide that by 12 to isolate my question mark. Divide both sides by this 12 molar. This molar takes out that molar, and notice that leaves my milliliters behind. So I only need 2.6 milliliters, tiny little amount. 2.60 milliliters of that strong acid is all I need. And then I'm going to dilute it to 250 milliliters with water, distilled water, to make that dilute solution. So those are quite simple to do. And you do the same thing if you're doing I'm sorry, if you're doing acid-base titrations. These acid-base titrations are exactly the same way. We're not going to do these analysis. We're not going to do these gravimetric analyses. You can do them. They're not difficult to do if you know the molarity, but we're going to take our time just doing titrations, acid-base titrations, and you're going to use that exact same formula: milliliters times molarity is equal to milliliters times molarity. Same thing, except you're going to be using a standard solution, and you're going to use that dilution equivalence point or end point. This is going to, again, be a Chem 2 topic. If you were to ever take Chem 2, you would do this, and you would go to the equivalence end point, and you would do, again, milliliters times molarity is equal to milliliters times molarity. And be done. That's all I'm going to ask of you. That's all I'm going to ask of you. I hope that you will get this, and I will talk with you a little bit more about exactly what to expect on your midterm, which is coming up next week.